students, welcome to Sunil's tutorial. I'm Sunil Nirvani and today we'll be doing the numericals of wave theory. A piece of ice has refractive index of 1.309. A piece of ice has refractive index of 1.309. A light of wavelength 5890 Armstrong units 5890 Armstrong units passes through it. What is its wavelength and frequency in ice? What is its wavelength and frequency in ice? Now guys, I can say this, that refractive index of ice with respect to air is velocity in air upon velocity in ice, right? We know that velocity of light in air is 3 into 10 raised to 8 meters per second. You're supposed to know this by heart. Therefore, I can say refractive index is given to you as 1.309 is velocity in air 3 into 10 raised to 8 upon velocity in ice. Hence, I can say that velocity in ice is 3 into 10 raised to 8 upon 1.309. I can also say that refractive index of ice, see how I write it and how I read it. Refractive index of ice with respect to air is wavelength in air upon wavelength in ice. Is wavelength in air upon wavelength in ice. You already know the wavelength in ice. Is giving you that wavelength in air is given to you. So I can say 1.309 is wavelength in air 5890 into 10 raised to minus 10 upon wavelength in ice. So you will come to know your wavelength in ice. Wavelength in ice is 5890 into 10 raised to minus 10 upon 1.309. Right? Once you have this, then you can find out frequency. The third thing they've asked you is find out frequency. Frequency VI. Frequency in ice is nothing but velocity upon wavelength. So that is frequency is velocity in air upon wavelength in air, or velocity in ice upon wavelength in ice. Either way, because even if light travels from one medium to another medium, its frequency remains unchanged. The answer for this sum you should get as velocity of light in velocity of light in ice is 2.29 into 10 raised to 8 meters per second. Then wavelength in ice is 4500 Armstrong unit, and frequency in ice is 5.1 into 10 raised to 14 hertz. Right? Now next sum please. A ray of light is incident on a glass sheet. A ray of light is incident on a glass sheet. A ray of light is incident on a glass sheet at an angle of 45 degrees. At an angle of 45 degrees. Find first part of the question, the angle of refraction, and second part of the question, the angle of deviation. The angle of refraction and the angle of deviation. If the refractive index of glass is 1.566. If the refractive index of glass is 1.566. Now guys, if I use Snell's law, I can say that refractive index is nothing but sin I upon sin R. I know refractive index. I should be able to get this sin R. I can say that sin R is sin I upon refractive index. When you divide this, you will get a number. Therefore, I can say that R is sin inverse of sin I upon mu. Fine, do we get this thing here? Now, once you have this, once you have the angle of refraction, then you can find out the angle of deviation. I can say that the angle of deviation is nothing but I minus R. You already know the value of I. You would have found out the value of R from here. So you should be able to get the answer. So in which case you will get this answer as angle of refraction is 26 degrees 50 minutes and angle of deviation is 18 degrees 10 minutes. Right? Click on next one please. A ray of light travels from air. A ray of light travels from air and is incident on a layer of benzene. A ray of light travels from air and is incident on a layer of benzene. And then passes to water. If the angle of incidence in air is 40 degrees, find the angle of refraction in water. Also find the net deviation produced. If the refractive index of water is 1.332 and the refractive index of benzene, also find the net deviation produced. If the refractive index of water is 1.332 and the refractive index of benzene is 1.501. Now, let's first consider for the interface between air and benzene. The interface between air and benzene, I can say that refractive index of benzene with respect to air is sin of I upon sin of R. Right? So in that case I can therefore say that sin of R is sin I upon refractive index of benzene. We'll call this as in benzene. So the angle of refraction in benzene is going to be this. So in that case I can say that the angle of refraction in benzene is sin inverse of sin I upon refractive index in benzene. Right? Once you have this, then I can say that now whatever is the refractive angle of benzene will be the same angle of incidence for the interface between benzene and water, alternate angles. So I can say therefore for benzene and water interface, the angle of incidence in benzene will be whatever is the angle of refraction in benzene. Now in that case, once I know this, then I can say that refractive index of water is sin I. Angle of incidence in benzene, angle of incidence in benzene upon sin R, that is angle of refraction in water, right? So in that case I can say that sin R is sin IV upon refractive index. So therefore I can say that angle of refraction in water is sin inverse of sin angle of incidence in benzene upon refractive index, right? So thus you will come to know the angle of refraction in water. Once you have this, then you can find out net deviation. Net deviation D. Net deviation D is nothing but the angle of refraction in water minus the angle of incidence in air, right? So in that case you will get this. Your answer for the sum should get the answer as refractive index in angle of refraction in benzene is going to be 25 degrees 21 minutes, right? Then angle of refraction in water is going to be 28 degrees 51 minutes, and your angle of deviation should be 11 degrees 9 minutes. Fine, do we get this thing here? Right, once you get this, then let's move on to the next sum, guys. Next, a thin walled beaker is placed on a rectangular block. A thin-walled beaker is placed on a rectangular block. Ray of light is incident on the surface of water at 60 degrees. Ray of light is incident on surface of water at 60 degrees. Passes through the water. Passes through water and then falls on the glass top. And then falls on the glass top surface of the glass slab. Calculate the angle of refraction in glass. Calculate the angle of refraction in glass if the refractive index of water is 4/3 and refractive index of glass is 3/2 and refractive index of glass is 3/2. We already know that angle of incidence in air is 60 degree. It is a replica of the previous sum. It is identical to previous sum where the ray of light is passing from one medium then to the other medium. Look at the previous sum and try solving this sum. Use the same method, only the numbers have been changed. So you should be able to solve this. I'm not solving this sum, I'll just give you the answer for this sum. You should get this answer as refractive index or angle of refraction in water. Angle of refraction in water should be 40 degrees 30 minutes and angle of refraction in glass should be 35 degrees 15 minutes. Look at the previous sum, use the same method and try solving it, right? Take down next sum please. Light is incident on a glass slab. Light is incident on a glass slab. Light is incident on a glass slab at an angle of 30 degree with the surface. At an angle of 30 degree with the surface. Find the angle of refraction. Find the angle of refraction in glass and velocity of light in glass if the refractive index of glass is 1.5, find the velocity of light in glass if the refractive index of glass is 1.5 and velocity of light in air is 3 into 10 raised to 8 meters per second. And velocity of light in air is 3 into 10 raised to 8 meters per second. Now they've said that the ray makes an angle of 30 degree with the surface. If it makes an angle of 30 degree with the surface, that means the angle of incidence is going to be 90 minus 30, which is 60 degree. Why 90? Because normal is always perpendicular to the surface and this angle is 30, therefore this angle has to be 60. So I come to know my angle of incidence. I can therefore say that refractive index of glass is sin I upon sin R by using Snell's law. Therefore I can say that sin R is sin I upon refractive index. Therefore you can say R is sin inverse of sin I upon refractive index, right? Once you have this, you will come to know your angle of refraction. What else have they asked you to find out? They've asked you to find out angle of refraction and velocity of light in air is given to you. They've asked you to find out velocity of light in glass. Okay. Refractive index of glass is velocity of light in air upon velocity of light in glass. Therefore, I can say that velocity of light in glass is velocity of light in air upon refractive index in glass. So you should get this answer as angle of refraction is going to be 35 degrees 15 minutes, right? And velocity you'll have to calculate. I haven't calculated, right? Take down next sum please. Take down next sum please. A plane wavefront is made incident. A plane wavefront is made incident at an angle of 30 degrees on the surface of a glass. A plane wavefront is made incident at an angle of 30 degree on the surface of glass. Calculate the angle of refraction. Calculate the angle of refraction if the refractive index of glass is 1.5. If the refractive index of glass is 1.5. Now you have to remember one very important thing here, guys, that if it is a ray of light, then you have to consider the angle with respect to the normal. if it is a wave front, you have to consider the angle with respect to surface. Here they said that a plane wave front is made incident at an angle of 30 degree on the surface. Therefore, your angle of incidence will be 30 degree. Here, instead of wave front, had it been a ray, then I would have said 90 minus 30. Right? The balance part of the sum is very simple. I can use Snell's law. I can say Snell's law. Refractive index is equal to sin I upon sin R. You know I, you know refractive index. You should be able to get sin R. Sin R is sin I upon refractive index in glass. So R is sin inverse of sin I upon refractive index in glass. You should get this answer as 19 degrees 28 minutes. 19 degrees 28 minutes. Fine, do we get this in here? Next, take on next one please. A monochromatic light is incident on a glass slab. A monochromatic light is incident on a glass slab at an angle of 60 degree. Is incident on a glass slab at an angle of 60 degree. Find the ratio of the width. Is incident on a glass slab at an angle of 60 degree. Find the ratio of the width of the beam in glass. Find the ratio of the width of the beam in glass to that in air if the refractive index of glass is 1.5. Guys, let's consider that I have a plane wavefront. Ratio of the width means I need to have a wavefront, right? Light reaches point A first, then it perpendicular and it reaches, this point is perpendicular and it reaches say point D. The angle of incidence is given to you here. Same way this is going to be that same angle of incidence that you will have here. Okay. Now after passing through the medium it is going to get refracted. This length is going to be perpendicular. Let's call this point as C. Right? So they've asked you the ratio of the width of the beam in glass to that in air. Okay. Now this angle is going to be the refractive angle and this angle is also going to be the refractive angle. This is going to be my angle of incidence. Right? Now once you have this, I can say that, let's try to find this out. Once you have the diagram, I can say that cos, I want to find out ratio in triangle ABD. I can say that cos I. Cos is nothing but adjacent upon hypo. Cos I is going to be nothing but AB upon AD. Right? Similarly, in triangle ACD, I can say that cos R is adjacent, that is CD upon AD. Now let's leave that there as it is. I can now say that refractive index, Snell's law. Refractive index is nothing but sin I upon sin R. Right? Now in that case I'll come to know that I'll get my angle of refraction. I'll get refractive index. Sin R is sin I upon refractive index. Therefore R is sin inverse of sin I upon refractive index. I'll come to know my angle of refraction from here. Now I can say that I need to find out the ratio of the width. I can say cos I upon cos R is going to be nothing but AB upon AD divided by CD upon AD. We had already found this out before. AD gets cancelled, so I'll get my ratio of width. I'll get AB upon CD is cos I upon cos R. This will give me ratio of width in air to glass, but I presume they've asked you to find out the ratio of width in glass to air. So reciprocate this. I'll get CD upon AB is cos R upon cos I. You know the value of R, you know the value of I. You can easily just substitute and get the answer. Fine, do we get this thing clear? You know I, you know R. Use your log table, cos I, cos R, and you should get the answer. The answer for this sum should be 1.633. Right, take the next sum please. The refractive index of glass, with respect to water and with respect to air, the refractive index of glass with respect to water and with respect to air is 3/2 and 4/3. Calculate the velocity of light in glass. Calculate the velocity of light in glass and water. Also find the refractive index of glass with respect to water. Also find the refractive index of glass with respect to water if the velocity of light in air is 3 into 10 raised to 8 meters per second. If the velocity of light in air is 3 into 10 raised to 8 meters per second. Now, I can say that refractive index of glass with respect to air is velocity in air upon velocity in glass. Therefore, I can say that velocity in glass is velocity in air upon refractive index of glass. You should be able to get the velocity in glass. Next, refractive index of glass with respect to water is going to be velocity in water upon velocity in glass. I've already found out the velocity in glass from the previous case, so I'll be able to get refractive index of glass and water with respect to air. Glass with respect to air and water with respect to air. They've given you glass with respect to air, so we've already found that out. And next they've given you refractive index of water with respect to air is velocity in air upon velocity in water. Therefore, I'll get velocity in water is velocity in air upon refractive index of water. The third thing that they've asked you to find out is refractive index of glass with respect to water. Refractive index of glass with respect to water will be velocity in water upon velocity in glass. Both those values you've already found out. So you should get this answer as, you will get the velocity in glass as 2 into 10 raised to 8 meters per second. You will get velocity in water as 2.25 into 10 raised to 8 meters per second, and you will get refractive index of glass as 1.125. Those are the answers that you should get. Right? Take down next one, please. the wavelength of blue light is 4.5 into 10 raised to minus 7 meters. The wavelength of blue light is 4.5 into 10 raised to minus 7 meters. What is its frequency? What is its frequency? If the refractive index of glass is 1.55, if the refractive index of glass is 1.55, what will be the wavelength and the velocity in glass? What will be the wavelength and velocity in glass if the velocity of light in air is 3 into 10 raised to 8 meters per second? Now, velocity of light in air is frequency into wavelength of light in air. So I should be able to get the frequency from here. I can say frequency is nothing but c upon lambda. Frequency is nothing but velocity upon wavelength. Next thing that they've said that what is its frequency? I found out the frequency. If the refractive index of glass is 1.55, what will be the wavelength and velocity in glass? Now, I can say that if light travels from one transparent medium to another, its frequency remains unchanged. That means I can say frequency in air should be equal to frequency in glass, right? Frequency in air can be written as velocity in air upon wavelength in air is going to be equal to velocity in glass upon wavelength in glass, right? But here I can say therefore that if I cross multiply, I can say velocity in air upon velocity in glass is wavelength in air upon wavelength in glass. If I cross multiply, if I take the wavelength on that side and bring velocity here, but we know that refractive index of glass is nothing but velocity in air upon velocity in glass. Therefore, instead of Ca upon Cg, I can write refractive index of glass is lambda A upon lambda G. Right? You have lambda G, you know wavelength. You know the wavelength of blue light in air. Wavelength of blue light in air is given to you as 4.5 into 10 raised to minus 7 meters. So you should be able to get the wavelength of light in glass. Fine. And once you get the wavelength, you should also be able to get the frequency. I can say frequency in glass is velocity in glass upon, yeah.
We got that frequency.
You already, no, here you just use that formula to get this. Right? We haven't actually got the numerical value, have we? I can, yes, you have, because velocity in air is equal to velocity in glass. You already found out its numerical value. So whatever is your velocity in air, velocity in glass will also be the same. Fine? The answer for this sum should be velocity in air is going to be, no, frequency in air is going to be 0.66 into 10 raised to 15 Hertz. That's my frequency in air. What else have I got to find out? I have to find out wavelength in glass, which I am going to get from here. Wavelength in glass is 2.903 into 10 raised to minus 7 meters. And I still need to find out the velocity in glass. So I can use the formula that refractive index in glass is velocity in air upon velocity in glass. So I'll get velocity in glass is velocity in air upon refractive index. There I found out the frequency. We haven't yet got the numerical value. We just use this Cg upon lambda g to cross multiply and get this answer.
Above.
That is velocity in air. I need to find out velocity in glass. I found out velocity in air from here. I haven't found out velocity in glass. They've asked me to find out velocity in glass also, for which my answer should come out to 1.935 into 10 raised to 8 meters per second. Fine? Right. We'll stop this here for the day. Thank you very much.